complex conjugate root theorem states that if you have a plus bi, or like 1 plus 2i, then the conjugate, the complex conjugate 1 minus 2i, would also be a 0 of that function. So write the simplest polynomial. Oh, by the way, the same thing happens with square roots. If the square root of 2 is a 0, then the negative square root of 2 would also be a 0. So write the simplest polynomial function with these zeros. 1 plus I, the square root of 2, and also negative 3. That one's normal. So remember, we write the zeros as like x minus that 0. So it said one of our zeros was 1 plus I. So that looks weird initially, but we're fine. Remember, if that happens though, if you have 1 plus I, another 0 would be the 1 minus I. 1 minus I. I'm going to need some more room here, and honestly, this is probably going to take a couple videos, so stay with me. Stay with me. All right, so there's two of them. Now we have this square root of 2. Oh, whoops, forgot that. So we have x minus the square root of 2. But when you have the square roots like that, it can also be the other version of it. So we'll say x plus root 2. And then this last one's kind of boring. It's just negative 3, so we write that as x plus 3. We need to multiply all of this. Now, it's going to get wild. I can guarantee this will take another video as well. We're going to mess with this at the end, this first part. Let's mess over here first. Here we have the difference of squares. It's the same thing except one is a plus, one is a minus. So that's a nice shortcut because you can square the first term. X times x is x squared. You always put minus, and then you square the last term. The square root of 2 squared would just be 2, right? Those are inverse operations, square rooting and squaring. So it'll just say x squared plus 2. Or you can FOIL all that out, and you'll still get x squared minus 2. We're going to multiply that by this x plus 3 right now, and then we'll deal with the madness. So if we FOIL this out, x squared times x is x to the third power. X squared times 3 would be 3x squared. Negative 2 times x is negative 2x, and negative 2 times 3 is negative 6. That is done for now. We're going to come over here. Let's see what we can get done over here. Now, I would say kind of distribute that negative sign. So if you distribute it here, it would become x minus 1 minus I, right? Because it's like you're distributing a negative 1 to both of those terms. Same thing here. It would become x minus 1 plus I, right? Because it would be like minus negative. So I'll show you a way on the next slide that you can also do problems like this, parts like this. But we've multiplied polynomials before, trinomials times trinomials. You just have to make sure you multiply everything in one set by everything in the other. So if I multiply all these by x, whoa, hello. X times x is x squared. X times negative 1 is negative 1x. And x times I, we can write as xi. Great, that's not too bad. Now let's get them all with the negative 1. Negative 1 times x is negative 1x. Negative 1 times negative 1 is positive 1, which I don't have any regular numbers here, so I'll give it its own spot. And then negative 1 times I is negative 1i. So I'll write that over here. Now we got to multiply the negative I. Negative times positive is negative. X times I is xi, so we'll have negative xi. Negative times negative is positive. 1 times I is 1i. And then negative I times positive I would be negative I squared. Great.